The coil is going to have to go on here with one leg in the air, and then we're going to have to run a wire over to the backlight enable resistors and over here. Jason, what is this? Jason, what the fuck is a backlight fuse doing on backlight enable?
Because I didn't know where the fuck this short was.
Why is there a fuse attached to backlight enable resistor?
I dug out all the traces and I couldn't
No.
find the fucking short.
And where is this going? What is this? This is interesting. I want to know what you were thinking here. Let's see what. All right, so today we're going to be going over an 820-3435 that is doing something really funny with backlight. I am excited because today I got back my secondary monitor so I can actually look. Well, I used to before it got blocked by a damn Windex bottle, but now I can see what you see all the time without having to deal with maximizing or minimizing windows to see what other people are seeing, and I like that. So let's turning off the air filter that Jason makes it a habit to leave on all day. And let's take a look at this board. So one of the issues that I have here is that there is a short circuit that seems to be present on backlight, but it's weird because it's not on backlight output. It's not on backlight output in and of itself. So what I get is, so what I did to try and relieve the short here, what I realized is that it's something in between here and here. Let's see how good this multi-screen setup is doing. All right. So what I noticed is this is backlight output over here. I have many videos on backlight circuit that you could watch if you don't know how a DC to DC to boost circuit works. But between here and here, there's a short circuit. So what I did is I removed this diode over here, right? And I measured on backlight output, and I had no short to ground. Then when I put the diode back, there's still something. So I thought maybe it's over here. The LED driver got removed, and there's still, it's still present. So what I did is I thought, okay, maybe there's a short to ground somewhere here. So what I did is I removed this coil, and I measured on this side, because keep in mind the coil is connecting this to that. I removed the coil, and over here, I have no short. I have no short here. But on this side, I have a short circuit. So I removed Q7706, which connects this section to this section, and the short was still present over here. So the short circuit is kind of present over here, but it's not present over there. So I just figured, okay, maybe it's one of these capacitors. I removed the capacitors and it's still there, which means the short circuit could be somewhere inside the board over here. So what I need to do is very simple. I need to create my own pathway for everything on here. So this goes to here. It's really stupid that they don't demonstrate this on the schematic. And then that also goes over to the backlight enable pin. So this is where the voltage from PP bus G3 hot, the main 12-volt rail, is going to decide to flow into the backlight circuit. This transistor is going to allow it to flow based on whether or not these signals are present, which means, if the computer is closed, don't let the light be on. If the computer is open, let the light be on, and so on and so forth. And then this signal over here, this is going to create backlight enable, which is going to tell this chip to turn on and work. So I'm going to have to recreate the pathway from here to here and from here to here, because somewhere over there's a short circuit inside the board. And as you can see on the actual motherboard, assuming the microscope camera works, who are we kidding? Who are we kidding with production here? Okay, so is it plugged in? Let's see. Okay, it is plugged in. Now, let's see if it's set to work. Okay, I have my HDMI splitter. I haven't been here in a few days, so I didn't know where to look. Okay, HDMI splitter is on. And show me some magic. Here we go. So here we are on the board. So this is where I removed the coil over here. So I removed the coil, which is connecting out, the backlight output here. And let's just show you what I get on the multimeter. So Jason is running because he thinks that there's a bad coil. All right, so check it out. So over here, multimeter, don't you work better when you're on? All right. Now on backlight output, I'm used to seeing 0.529, but here, obviously you're not going to see anything. That's not a short because I removed everything. Here there's nothing. But on the input of the coil, I see 0.121. And sometimes it goes down. Now on a regular board that hasn't been destroyed, on that section I should be seeing something like 0.3, 0.381. Now, You could see I also removed the transistor that's behind it. This is where that 6-legged transistor is. 1, 2, and then 3, 4, 5, 6. And over here, same thing. So that transistor is going to have to go on here with its legs in the air. The coil is going to have to go on here with one leg in the air. And then we're going to have to run a wire over to the backlight enable resistors and over here. Jason, what is this? Jason, what the fuck is a backlight fuse doing on backlight enable?
Because I didn't know where the fuck this short was.
Why is there a fuse attached to backlight enable resistor?
I dug out all the traces and I couldn't
No.
find the fucking short.
And where is this going?
So-
What is this? This is interesting. I want to know what you were thinking here. Let's see what the hell is this? Okay, that is one. That probe point is for PP bus G3 hot.
Yeah.
See, we're trying to run PP bus G3 hot directly to here.
Yeah, because I thought the short was under the fuse.
Okay, you honestly that wasn't a bad guess. That wasn't a bad guess at all. What do you think, Olga?
I think like you. Like you think.
You're worse than the fucking students. Anyway, I think.
Oh, God.
Yes.
Thank you.
Man. I think what you think. That's not an answer. That's the answer that I used to give to Mr. Pelenkovic when I wasn't paying attention in class. I'm kidding, Olga. I didn't mean it. I'm sorry. I didn't mean it. Oh, I kind of did. Okay, yeah. So let's see if we can make this work. So what we have to do here, just to recap, this section of the board here, and this is shorted to ground. But it's not shorted to ground all the way. It's shorted to ground a teeny tiny bicicleta, as Cartman would say. Little bit. So this transistor is going to have its legs in the air. The coil is going to have its legs in the air. This is going to be fun. I'm going to have to find a way to fit a capacitor on the leg of the coil that is in the air. So we're going to be doing some acrobatics. Are you guys excited? All right. Where the fuck do I even start here? All right, so I guess I would start with... Man, where do you start with this? Okay. Let's start with the transistor that has to have its legs in the air. I lost the orientation of the transistor that I was stealing off of a donor. Your worst. You can't see anything, but this is just the board I'm stealing from. Nothing to see. Nothing to see here. Just me taking my transistor. Now I have to turn this thing around because it's the opposite way on the 11-inch from the 13-inch board, so this is not the orientation. So the way I'm going to remember the orientation is BO, body odor. So it has to be upside down so that it says BO. Now the problem here, besides the fact that it's like a dead bug, it refuses to sit up. So I have to have it touch this and this without anything touching that and that. So what I figure I should do is I might as well wick that area off the board since I'm not going to be using it anyway. Now, what would be really cool is if I could just rip those pads off, but those are not coming off. They're very thick pads in a very thick area. So I'm not going to have any luck trying to rip those pads off if I just tried to do something like this. And if this was an iPhone, this would be a, they'd be gone already. But the one time that the pads are not going to come off is when you want them to come off. You can see a little hole over here where the backlight fuse used to be. Anyway. Jason's laughing. You didn't happen to put a hole in the board, did you, Jason?
On purpose, yeah.
That's what I like to hear. Okay, so this transistor is going to sit like this. What do you want? Hey, what do you want from me? It's a one-off motherboard repair. This is not going into the space shuttle. If this was going into the space shuttle, then you're allowed to bitch. So we're gonna do this. That was a tricky short. 0.125 instead of point. Hey. Hey. Come back here. This is not going well. My day back at the office is not going well. I've been out of the office for several days, and my return to the office is not fruitful. Let's try that again. This says B7, close enough. That's the orientation. All right. It's see, soldering it on there is not hard. It's making it do the wheelie without touching the board that's being a pain in the ass. So here I'm satisfied that it's doing a wheelie and it's not touching the board. Let's check this side over here. It's clearly not touching the board. Alright. So now I gotta see if there's continuity between here and the pins. And there's none. Open line. There's no continuity at all. I'm happy about that. Alright. So now I have to put the damn coil on sideways. So that's gonna go directly to the coil. And this capacitor is going to have to go in its mouth. Oh, the motherfucker. Okay. Let's just get the coil off and go from there. So I'm going to take the coil off of another motherboard. It's hard to remove. It's very large. Lots of thermal mass. So I just took the nozzle off the JVC to make this easier. Okay. Now remember, the left side is shorted to ground. I can't do anything with that. So I'm going to solder the coil on a lift, like this. Then the computer's not going to close, so All right, so I'm going to have to do a bit of a wheelie here. So the coil is going to get soldered on with a wheelie. And hopefully that doesn't make my FET move. But it probably will. Yeah, it made the fucking FET move. That is that's some. Yeah, I don't know how much I can trust that. And now keep in mind this capacitor is going to have to go on its side. And let's see, which side of the capacitor is the ground side? For that capacitor, the right side is the ground side, so alright. I'm pushing it against something, so now I can do this. Hey! Come on, stand up. Okay, so right now it's standing on ground. Yeah, I should have done the sequence of this the other way. Alright, so let's try. Standing on ground. And let's get my heat back. Now this has to go to there, which has to go to here. I think if I solder the wire onto that this first, it'll make this easier. And I'll tell you why I'm leaving so much slack on a little later. First thing I have to do, I'm going to move over to a different motherboard now that's broken. I'm going to use the broken motherboard to do a little bit of wire stripping. So I'm going to add a little bit of flux to the wire, and I'm going to add a little bit of... My flux decided to fall right on the part of my jeans that had a hole in it. You can't make this stuff up, man. Alright, let me just clean that off, because that's nasty. Let's see, I'm going to try... This is what alcohol is for. I'll figure I have a small hole in my pants, and that's exactly where the friggin' flux decides to fall. That's taken care of. All right. Anyway, where was I? I'll just get a new wire since I don't know where I was unstripping that one. So I'm going to take a piece of wire, take the flux and not drop it this time. Do this. Now I'm going to take some solder. Add it to my iron. I'm going to hold this in place. I'm going to scrape. Add flux. Scrape. Okay, now we go back to this motherboard, the one I'm actually working on. Going to attach it to the legs. But before I do that, I'm going to want to tin the legs just a little bit. Not a lot, just a small bit. Top of the capacitor. That could definitely use flux. That joint came out really crappy because it had no flux. Everything looks nicer with flux. Now let's just, I'm going to make sure that it's still not making any contact with the board. I'm going to do my measurements. There it is. I screwed it up. Okay. Let's lift this up just a little bit more. This is a pain in the ass. Now it looks like a spider that's climbing a skyscraper. Okay. It has to go to the capacitor. Which badly needs flux. And another dab of solder. It's burning away very quickly because there's no board to absorb the heat. Okay. I should have pre-exposed this section too. Better late than never, I suppose. We're going to attach this to these two legs of this transistor. Hey, it's not pretty, but it'll work. Come on, get exposed. Come on, little wire, get exposed. Get exposed like Jason Blaha. There's a. All right, that's good. That wire is as exposed as Jason Blaha at this point. I'll be interested to see if this shit works. This looks bad by my standards to be. No, I mean, like, what I'm doing right now is just disgusting by my own personal standards for what is disgusting. I'm trying to expose this wire after the fact. I should have exposed it earlier. But I think it's attached now. Yeah, the flux and everything, that's fine. Now all I have to do is get this fucking coil. Off. But it's soldered on the other side as well. See if I can get this off without hot air. Awesome. Alright, so now the coil is going to go on like so. It shouldn't be that easy to move the damn coil, but what do you... Oh. So this wire is then going to come around here and go to the side of the coil. This is as good as it gets, man. Part 1 of this is almost complete. All right, part 1. And the best part is I didn't make any short along the way. Awesome. Now the second thing I got to do is... So PP bus G3 hot is going to a backlight fuse. Over here. So Jason got a good amount of the way. Now remember, this is the voltage divider over here, the 2 resistors for backlight enable, which is over here. So PPVin SO SW LCD backlight, PPVin SO SW LCD backlight. This is the part that was shorted to ground. So what I was doing is I was making a wire between here, the capacitor and the coil, and I had these all detached from the board because this is shorted to ground. This is shorted to ground, which means this is shorted to ground. So pin 1 of R7731 has to be turned around. So pin 1 of R7731 is going to be this. So I have to turn that resistor, and I have to run my wire to that as well. But before I run my wire to that, I'm going to want to solder an LED driver on here. So let's go back to my view in the microscope. And first thing I'm going to do is I'm going to get an LED driver soldered on the board. Luckily, I have a lot of these left. I got a nice big spool. Stay. Sit. Until I get a JBC nozzle that's not totally bent, I'm just using it without the nozzle right now. That's fine. So I have to get used to it. It's hard to put pressure on small chips when the nozzle's not there. Did it shift into place? Did it... Finally. Okay, so it shifted into place. I can do a quick examination of the balls to see if they're up to inspection. They're up to quality, and it looks like they are. Alright, so now remember, this resistor over here, I have to move it around, and then I have to attach it to my wire. This is going to be a little difficult because that wire is thick, but I felt the need to use a thick wire because that's being used for the entirety of the backlight voltage. Now what I'm noticing is that resistor doesn't seem like it has that cap anymore. Huh. That's fine. I'll just grab a different one from another board. That resistor's had its days. It's done for. We'll grab a different one. Take this one. Now this is going to be a tough one. I don't have a lot of clearance. Yeah, this is exactly the same quality as that Dino Light camera. Same thing, right, guys? And girls, and everybody else? I still can't believe they had the audacity to send me that and think I would actually say something good about it. I just don't understand companies that do that. I really don't. Alright, so this is my wire from the other side. Looking all pretty. We're going to take that wire. And that wire is going to get routed to here. Let's zoom out, make it easier to see. Jason unplugged my iron sleep, so I was wondering why I wasn't beeping to sleep when I put it back in the thing. I think Jason just wanted my iron to die. That's not nice. Alright, so I'm going to route this around. And wow, there's no clearance on this. This has got to be exact. Alright, so... Okay, flux. I need a solder blob, and I need to rip away as cleanly as I can. Solder blob. No! The other side wants to come desoldered now. Oh, god damn it. This wire is thick for this purpose. Pain in the dick, man. Maybe I should run a second wire over that's thinner, just for this. Because this doesn't take any power at all. Yeah, making this one long wire is not a good idea. Alright, so... do this. Wait, now you're back where you... I have to get you on sideways. Alright. So this is just going to get terminated off here. Doesn't need to be here. And I'm going to run a second wire that's very thin over to that resistor so that it's not going to shake anything off. So I'm going to plug in my micro pencil iron in a second. And we'll get that done. And this will then wind up looking very pretty. And it'll have a backlight. Now I can't forget I have to put the fuse on as well. I'm probably going to forget to put the damn backlight fuse back. Because there's no fuse on it right now and there's no pads for the fuse. Oh, but that's one of those simple problems. We can fix that later. That's the part that we aim to fix once this nightmare mess is done. Alright, so I'm just going to ready my micro pencil. It doesn't have its strain relief on it anymore for some strange reason. Here we go. Beautiful strain relief on my pencil. Nothing like a $150 iron with a strain relief that lasts for a month. And we're almost to the end. Need to borrow a piece of thinner wire. Where's the... Remember, the reason I can use thinner wire here is because that using very little power. You can see on screen over here, it says 200 kilo ohm and then a 100 kilo ohm resistor. That's not going to be using anything. So I can use this really super thin wire here. So I'm going to run the wire from the resistor. I'm going to start at the resistor. I'm actually going to turn this around to do that. Okay, we expose some of this wire. Bam. See, this is much better to work with. Now I got to get rid of that little excess. And in getting rid of the excess, I desoldered the whole thing. Good job, jackass. All right, try that again. First, I need a little bit of solder on the this tip. Come on. It's turning into a little bit of a mess. Ah, these tweezers don't have legs. That's why it's not grabbing anything. I ordered a better set of tweezers. Hopefully that arrives soon. Okay, so... let's try this again. We're going to put a little piece of flux on there. We're going to come by with a little molten blob of solder. We're going to push it in with the tweezers. It's going to be beautiful. But these tweezers can't do anything. They can't grab. Fucking pieces of shit. How about this? Can you grab like this at least? Okay, kind of. It looks like it's soldered to the resistor, but it doesn't stick. All right, let's try this from the other way around. Ah, that resistor may just not have its pad anymore. Alright, try a different one. We'll grab another resistor. No biggie. No biggie. But I forgot that I've stolen that resistor off of everything. So that I don't know where I'm going to find that. Yeah, that was the wrong resistor to... not that. That is. That resistor is gone from every board. Stolen, stolen, stolen. Okay, last one. Can't screw this one up because there's no other resistor after here. You know what? I'm going to get a different pair of tweezers. They're the best pair of tweezers in the store. This makes me sad. Okay, we'll use these. Come on. Move, little resistor. Oh. As soon as I came back to the office, the JBC went down. I was wondering why the resistor didn't want to come off. It said cooling on it. Here we go. The resistor has come off. Okay, there we go. Now I'm gonna... Let's try this again. Okay, now we're gonna take a wire. Take a thin little wire. My thin little wire is... Oh, my thin little wire disappeared. Yeah, my thin wire disappeared. Time to steal another one. I can't even see it. It's literally, I put it down on my desk, and I know it's sitting there. I just can't even see it. It's that fucking small. I know it's going to be, I'm going to see it later. I'm going to sit on it, or my shirt's going to get stuck on it or something. Alright, so put some flux here. Put some solder on the tip of my iron. Much better. See how that's stuck on there? Oh, you... Now let's just make it flat on the board because it's not flat. Okay, that's flat. Now I can run this wire around. And it's going to go to that capacitor. So I put a bit of flux in the capacitor, which makes that a flux capacitor. Flux. Okay, it's connected. Let's see how god-awful that looks on the other side of the board. What are you gonna do? It could be flatter if I pulled it tighter. I'll just have to green it or actually. Let's just run it straight. Like this. That'll be better. I was trying to wrap it around something, but that was just making it more of a mess. We'll just do it like this. Did I just pull the resistor off on the other side? Phew, I didn't. I thought I did. Alright. That was close. Forgot, can't pull. Alright. Okay, it's up there. Now the last thing I'm going to have to do here is go to the damn backlight fuse to hit over here. And now I have to find PP bus G3 hot somewhere on the board and wire the backlight fuse in. And this will be set and done. So, backlight fuse is supposed to go over here. And PP bus G3 hot can actually be found somewhere over here in the PP3V42 area. So let's see. So PP bus G3 hot. And if I look on the screen, PP bus G3 hot is supposed to show up on the fuse, and it's also supposed to show up on pin 1, which is the right pin of the bottom resistor that you can see over here. So we're going to run a little wire from here. And I'm going to have a fuse sticking right off the side of the board over here. And this is another one where I'm going to want to use a thick wire because this is carrying total voltage for the backlight circuit. So add some flux in there. Let's move it away from the capacitor. Tinned one side of this. We tinned one side of that. So now I'm going to run a wire from the backlight fuse to the PP3V42 area. Let's just get us a wire here. This will be a fine wire for this short length that it's going. I just got to tin the wire. I can grab my spare board with the nasty metal piece that I was using for wire tinning. Do this. All right, beautiful. Now this is tinned. Go back here. Okay. Squeeze you in place. Rip off the excess. Okay. Now, you run this right along here. Oh, to the Okay, and here we go. So PP-G3 hot is now going to the backlight circuit via this line to the fuse. And let's just make sure that that's nice and pushed in there properly. Wow, that looks like shit, man. Okay, and let's just check and see if there's any shorts to ground, anything that we have to worry about at any one of these areas. So backlight output on this, I want to be 0.519 to 0.546, and I got 0.526, which is perfect. My backlight fuse is conducting. So all I need to do is find a screen that's not broken, plug it in, and see what I get. This is the fun part of my day. So this is a screen I should not plug in. That's bad. I'm putting it right back in my pile of testing stuff because I'm an idiot. Okay. Wires everywhere. HDMI this, HDMI that. Go. Jumpers. The donors can go get shoved in there. Let's make some space for testing, shall we? I hate these short LCD cables. Okay. Let's see what we get. Actually, let's just make sure there's no short to ground with the screen plugged in. I don't want anything to go on fire here. Yep, there's no short to grounds here. Let's see what I get for backlight output. Hey, damn, the DCN cable popped out. Stay. Come on, be a good little test setup. This is the 2013-14 Air, so it's going to turn on, turn off, turn on, turn off, turn on, turn off, and then finally turn on, during which time I will probably have fallen asleep. Let's see what we get. Hey, what do you know? An Apple logo. Bam! And this is the part where I move it out of the way before you see the person's face, full name, or user ID. Because if I show you that, you will stalk them, as is my sad prior experience. Anyway, I may cover a small portion of it. Yeah, I'm going to cover the names because that you'll stalk them. Guest user, and bam. So let's just go over what this looks like on the microscope camera. One more time, and I'll go over in the schematic one more time what it was. And then this can get tossed back for ultrasonicing, and because it badly needs it. So as you can see on the microscope camera, there was a short to ground on the board on the line between here and here, so the coil had to go up. This capacitor had to go up because this capacitor is storing power right before the coil. What powers the backlight, since power to the backlight circuit is this transistor, so this transistor, which goes over there, had to go up. Since after that transistor, it not only just sends power to the backlight circuit, it also sends power to, why did I leave this on here? Get off. It also sends power to this backlight enable resistor, so that wire had to go down there. And a wire also had to go from a PP-G3 hot to a backlight fuse because there's a hole in the board where the backlight fuse is supposed to be. On the schematic over here, you'll see this is the part that was shorted to ground. So right over here And here, it wasn't a full short to ground, but it was 0.12 on diode mode rather than 0.38 on diode mode, which is what I would expect at that area. And by expect, I mean I gave up and I was confused, so I measured on another board that was right next to me to see what I was supposed to get. As I always say, this is always about just, again, having scrap stuff. The reason it's more difficult to fix other items. How am I supposed to know what I'm supposed to get before the coil? How am I supposed to know what I'm supposed to get there if it's supposed to be 0.12 or 0.38 on diode mode to ground if I don't have another board to compare with? Having another board to compare with is not only helpful, it's what makes learning possible. And without this, it's a nightmare, which is why I don't do one-off, no-fix, no-fee repairs of other devices because I don't have, if somebody wants to send me some random, because I get these requests all the time, like, will you fix this board that goes into my automatic oven thingy? Do I have another automatic oven thingy to compare it to? And if the answer is no, and if I'm only getting paid if I win, then it's a real, but yeah, that's it. And as always, I hope you learned something. And with any luck, if you ever have to do something like this, well, you'll do it neater and faster than I did.